Let's go ahead and practice naming points, lines, and planes. For number 1, we're going to use the diagram to the right to name the following 4 collinear points. Well, I know that collinear means that they're on the same line. So one line that I see is line R. On line R, I see that 4 collinear points are H, N, K, and I. Can you name 4 collinear points from a different line? Moving on to B, let's look for a line that contains point M. So if I look for point M, I notice that that's on line P. For C, I'm looking for a line that contains points H and K. So H and K are both on line R. For D, if I'm looking for another name for line Q, I can see that Q has the points J, K, and L, and I know that I can name a line with 2 points. So I can call this line, and looking at line Q, I see J and K and L, so I can call this line JK. There are other names. Can you think of other names for line Q? And for E, I'm looking at the intersection of lines P and R. So if I look for line P and I look for line R, they intersect at point N. For question number 2, we're going to use a diagram to the right. So for 2A, I'm looking for a line containing point F. So if I look for point F, I see point F is right over here. So the line that contains point F would be referred to as line J. For B, if I'm looking for another name for line K, I see line K is right over here. Notice that these dots refer to that line going through point E from one side of the plane to the other side of the plane. So going back for 2B, another name for line K would be BC. So I can just put a small line to denote that I'm referring to line BC. For 2C, a plane containing point A. Well, point A is located right over here. And this is on plane M. So notice that the capital letter M is in a script form, which denotes that's the name of the plane, as opposed to a point on the plane. So I would call this plane M. For number 2, an example of 2 non-collinear points. So non-collinear means they're not on the same line. So I see on line J, I see point D, and on line K, I have point B. So those are non-collinear, so those points would be an example of 2 non-collinear points. And the last one on number 2, the intersection of plane M. So this right here is your plane. So where does the plane M and line K intersect? So here's line K. So this is a line coming out from underneath. and this dotted version refers to it's behind the plane. So it looks like the intersection, where do those intersect? Right here at point E. So next example, let's go ahead and use a diagram at the right to name the following. So here I'm looking for 3 coplanar points. So coplanar points refer to points that are on the same plane. So one example would be Z, V, and W. Z, V, and W all are on the same plane. In this case, this is considered a plane. For 3B, a plane containing point X. So I see that point X is located right over here. So point X is right over here. So a plane that contains point X, we could refer to plane R. So plane R, notice it's in that script form. So that's the script, or cursive looking. That describes this plane here. So that's plane R. So we could say plane R contains point X. And for number 3, the intersection of plane R and plane ZVY. So first let's look for and highlight where plane R is. You know that plane R is right over here. And plane ZVY, so ZVY is right over here. So where would you say there is an intersection of plane R and plane ZVY? The intersection takes place right here between points V and points Y. For 3D, how many planes appear in the figure? Well, if I look at my figure, I can see that I have already highlighted 2 planes, plane R and plane ZVY. I can also identify another plane. This is plane ZXW. And another plane that I see is plane ZVW. And I see another plane, which is plane ZYX. So it looks like I have a total of 5 planes. Last one, for number 3, how many planes contain point W? So point W is located right over here. So point W is on plane R. Point W is on plane WXZ. So this is another plane that contains point W. And point W is also on plane ZVW. So the 2 planes that contain point W are here, and a third one that contains point W would be plane R, which is this plane right over here. Plane R contains point W. So that would make a total of 3. Last example, we're going to use a diagram to the right to name the following. A, the intersection of lines L and M. So if I look for line L, I see line L is located right over here. This is line L. And line M is located right here. So when I'm looking for the intersection of those lines, the intersection of the lines take place at what looks like point E. Next, I'm going to look for another name for plane Q. So plane Q is located right over here. Here's plane Q. So I can name plane Q using 3 non-collinear points. So for example, I could call plane Q, I could also call plane Q plane FGI. F, G, and I are non-collinear points on plane Q. Number 4, C, are points D and E collinear or coplanar? Points D and E are on the same line. They're both on line L. They're on different planes, however, because we have 2 planes. We have plane P and we have plane Q. And points D and E, you can see they're on different planes. So they're not coplanar, they are collinear because they both are on line L. So we would say they are collinear. And last question, how many times do planes P and Q intersect? Well, we see a line intersecting the planes, but are the planes actually intersecting each other? In this case, they are not. So the answer would be 0. Thanks for watching this tutorial on dimensions. I hope you learned about lines, planes, and points.